In this video, we're going to begin to cover inspecting a surface plate. Now that involves resting our gauges and our part on a granite surface plate and using that as a reference surface for taking our measurements. This can be very useful, having a flat reference to work with, and it'll give you more options than the standard hand tools will give you. It's a great skill to have, not only for its accuracy, but also for the wide variety of inspections that you can do. I'm going to be splitting up this topic into multiple videos because it's going to take a while. But let's take a look at what we're going to cover in this video. So we're going to start off covering the basic gauges. So we'll talk about the plate itself, the height gauge, the drop gauge, and a drop indicator and a test indicator. So these are the basic tools you're going to be using in any surface plate inspection. And we're going to work in the accessories in another video, but you'll see here we're going to work in 1, 2, 3 blocks and V blocks, Joe blocks, sign bar, gauge pins, angle blocks, jacks and clamps, and in fact, we're gonna have a separate video just for these working in these accessories, and then I'm going to do another video where I talk about measuring angles, and I'll work in the sign bar and the angle blocks. So, like I said, this will be split up into a few videos, but there's a lot to cover. So let's get started. I like to start off by telling people when you're using surface plate inspections and you're going to be integrating all these different accessories that imagination and creativity are going to be your allies, because you're going to be challenged to do some inspections where it may not be straightforward. You may have to set up an interesting fixture or use multiple reference surfaces to get to your final value. Do a little shop math. Shop math will be radiuses of holes and angles and triangles, additions and subtractions. So you'll be using a lot of shop math when you're working these tools, and I'll show you that when it happens. But there are really infinite combinations of the gauges and the accessories you can work in. I'm really going to try to cover the most basic ones and get you ready to come up with your own when you need to set up for something specific for what you're doing. But I won't be able to cover everything. So I've got the most common equipment that we'll go over. And then for every setup, what you really need to consider is how accurate is it? Is it repeatable? How simple and secure can you make it? How many steps are involved? Can you shorten the number of steps? There will often be zeroing and moving and zeroing again, and maybe more movements and shop math involved. So how can you simplify that process? So you want to find the right balance of creativity, complexity, effort, and what you're trying to get to in the ultimate output. And when you consider all that, sometimes other gauges might make more sense. If you need a really complicated surface plate setup, maybe it's time to go to a CMM, optical comparator, or maybe it's time to use a hand tool. And it may be that doing a hand tool is maybe doesn't have the accuracy you're looking for, but you can't set it up on the surface plate in a repeatable way. So it works out that the hand tool's better. So let's keep that in mind as we go through some of these topics. But we're going to start off talking about the plate itself. So let me clear off these gauges out of the way. So the surface plate itself, it's the most important piece of any inspection, and we need this to be very flat. If it's not flat, then anytime we're resting a gauge on it or a part on it, it really affects our results as we move our gauges and parts around and we get different flatness on the plate. Well, the parts can be sitting at different heights when that happens, and you can't trust those measurements when you have a plate that's not flat. So it also needs to be reasonably level. Now it's not super important to get it down to like micron accuracy of level. A bubble level, any decent bubble level or electronic level will help you get it a relatively level enough for you to work with. Many of these larger plates, larger than this one, will come with some jacks, some feet that you can change the leveling of the surface plate using the jacks. And usually it's 3 jacks relatively evenly spaced so that it makes it easier to work with. Keep in mind that a lot of surface plates will be on rolling carts to roll around the shop to different levels, and then your flatness is really going to be dependent on how flat your floor is and how rigid that cart is. So sometimes carts will have leveling capabilities as well, so you roll it to a new area and you level it. You should try to do that as much as you can. Keep it as level as you can, but really you're not incredibly dependent on gravity for this type of movement to work. You just want it to be reasonably level, so you're not seeing any big errors because you have it way out of flat. And as they get even larger and larger, I used to work with some very large plates, multiple feet long and wide. They might have even more jacks than 3 or 4, and those may be a little bit harder to level, but you may need to shim it. You may need to work with your floor itself to get it level. So just do your best effort. Now, when we're talking about grades of surface plates, just like any tool, is how accurate is it? When we're talking about micrometers and calipers and hole inspection gauges, we talk about some are more accurate than others, and plates are just that same way. We grade them from the most accurate grade AA. That's for laboratory use. So research institutions, the Gage manufacturers themselves might be using grade AA. But grade A and grade B are more what you're going to see in industry. And grade A has twice the error allowance as grade AA. And grade B is toolroom grade, and it has 4 times the allowance of grade AA. So we're talking about maximum amount of error. And it's actually length dependent. So as these plates get larger and larger and larger, you work with the diagonal of it to figure out the maximum allowable error. So a small plate is going to have a small allowance for error, and a larger plate will have a larger allowance. For a 12 by 18, as an example, I don't think this is a 12 by 18. I think it's I can't remember how big this one is. But as an example, a 12 by 18, grade AA, you have 60 millionths, and grade A, you're going to have 120 millionths, and grade B, you're going to have 240 millionths or 2.5 ten thousandths. So still not a lot of error allowed in a plate like this. This is a tool room grade right here, and I really have no issues doing it for the type of work that I do with this plate, or many other applications for tool room grade. You don't always have to use grade A or AA to get the most accurate out of it. Depends on how accurate parts you're working with. So each plate is going to come graded from the manufacturer, and their actual, as they wear away, as you run your heavy gauges over them over and over and over again, well, they will start to wear away. And they actually could be starting off at grade AA, and as they get used more and more and more error, well, now they can't be certified to AA anymore, but maybe they can be certified to grade B, and it can be used as a grade B. So they do change over time due to wear. This is the formula. Right here is the formula. And so flatness is calculated by this 40 plus the diagonal of the plate squared divided by 25 times 1 million. And this is how they calculate the maximum error. So really, you don't need to know that, but in case you're curious, this is how they're calculated. Like I said, using the diagonal of the plate. But if you compare flatness error, right? Flatness error, pretty tight, but within the normal tolerances we've seen for some gauges, especially at grade B or grade A. But when we talk about repeatability of plates, it's actually held to a much tighter tolerance. And what that means is when I put this part on the plate at this point, and I take it off and I put it back, we really need it to repeat. Otherwise, again, if it doesn't repeat, it's not a valid gauge to use because it'll mess up my measurements. Same thing when I'm sliding around my height gauge. And you know, if I move it here and then I move it over here, I need it to repeat when I come back. So you'll see, you know, if we do our 12 by 18 surface plate, we compare the tolerances of repeatability and flatness, we have about half of the tolerance roughly. And again, it's using the diagonal of the plate to figure out these tolerances. I'm not going to give you the formula. I'm not even sure I know the formula. I could look it up. But for you guys, it doesn't matter. These are going to come graded from the manufacturer already. And you can just use that grade to figure out what class you need to buy for what part you're inspecting. Now, when it comes to calibration time, an outside service is probably going to be what comes in and does your calibration for you. They're going to use a repeatometer. It's a very specialized gauge for measuring flatness on surface plates, and they're looking for dips. So they're looking for these dips in the plate, and that indicator is just going to move back and forth, and however much it moves is your flatness error. And how they, skipping ahead of myself, how they do it, they'll take their repeatometer and they'll run it straight lines in a few locations, and then they'll go to 90 degrees and run it again, and they'll just look for the maximum error on that indicator. And that's about it. Now, you could certainly purchase one of these yourselves, but they're very, they're quite expensive. But if you have a lot of surface plates and you had a cost-effective reason to do it, go right ahead. It's not very hard to do. You do need to clean this off with some surface plate cleaner. Get all the dust and oil off the surface of the granite plate, and then run your repeatometer across it. Now, if it goes outside of tolerance, we'll talk about what you can do. But before that, we're going to talk about how you can check it in the shop very quickly without a repeatometer. You can use a height gauge and a Joe block. So I'm going to show you a picture real quick. So what we're going to do is we're going to set up a Joe block on the surface plate, and we're going to zero it at one corner, and then we're going to go around to multiple places, and we're going to check that everything remains zero at every place we check with our test indicator. So we haven't, I'm just now getting started. We're introducing you to a test indicator and a Joe block, but for the most part, we're going to really go in depth on those later. But for right now, we're just going to focus on how we do it with a surface plate. So how to do it, first of all, set up a height gauge with a test indicator. I already have one loaded here. Select the Joe block in 0. So I'm going to select the 250. I think it's a good size to work with. And we'll put on a rock for now. Then we're going to rotate the height gauge and the block around the surface plate. Sweep the block to find 0. So, on step 2, we're zeroing the indicator, and then we're just going around. Now we're going to switch the position of the block and the surface plate, and the height gauge on the surface plate, and there should be no difference. So if I have my block on one corner and my plate on another corner, and I switch their position, I should get the same reading. If I am at different levels when I zero, and then I switch the positions, the indicator is not going to go back to 0 because I was zeroing at one level, and now I've raised or lowered the height gauge relative to the Joe block, so it won't go back to 0. And if there are any dips, you should see a difference in the indicator movement. So let's switch to the second camera and do that. Move this out of the way. So first of all, because this plate is a little bit small, I am going to have to angle my indicator at quite a 90 degree angle almost, just to get some space. And we're going to try and get this tip horizontal. We'll talk about that, close to horizontal. We'll talk about that in a little bit. We're going to wipe off our Joe block of any dust. I've already cleaned off this plate with some cleaner earlier, but check it again. It feels pretty smooth. I don't feel like there's anything on it. And we'll set our 250 Joe block. Actually, doesn't matter really what size you pick. All right. and we will 0 it. So we're going to put our indicator to 0. Oops, you know what, I ran out of travel on my height gauge. You can see I've bottomed out here. So what I need to do, quick fix for that, I need to angle this downward and then adjust my angle. Alright, let's try this again. Okay, and I've got 0 on the indicator. If you can't see it up here on the screen, check out the secondary camera feed where it's a little easier to see. So I have 0, I'm going to slide my block out, slide it back. I still have 0. Now let's go to some other places on the rock. Looks like 0 to me. Let's go. Now let's try to do our reverse. Let's see. Now you probably can't see it too well on the screen, but it does still read 0. I've switched the positions of the corners, and let's try to avoid hitting the camera and do this corner. And I've still got 0. So overall, if you just go all around the corners and the middle, and just keep repeating this method, you should see 0 no matter where you go. And that'll be a quick way to check your plate. Now, this is only involving tools you should already have in the shop. You need a calibrated indicator and a calibrated Joe block to really trust the values, but you should have those in your shop already. All right. Now, if you fail calibration, whether it's your in-house check or from the calibration company, what they'll offer you is a chance to resurface it, and they'll do it with a dry lapping process. So they'll basically dry lap the top of the surface with a steel plate with some grooves on it, and as they drag it across, it'll remove some material. And it's a skill that I don't have, but it's pretty impressive to see when they the guys come in and they can just feel the flatness and double check it with their indicators. But they can work it back into tolerance that way. So they'll be removing a few, gosh, I don't know how much to even remove really. Just the real top surface where you had an issue until it gets flat again, and then it'll be back to the tolerance you need. Now you have the other option I mentioned before. You can regrade it. If you started out at grade AA and now it's grade B, well, maybe you can no longer use that plate for the application you were using it for, but maybe you have another application where it can be used. Yeah, maybe it can't be used in the research lab anymore, but your tool room might be able to use it, so you could recertify it that way. Talk to your calibration company about that option if you don't have the money at the moment to resurface it, or even maybe you just don't need the grade AA anymore. Maybe you got it for one purpose and now you don't need it for that purpose anymore. It just comes down to whether grade A, grade B is good enough for what you're doing. And for most applications, I would say that's an option. So we're going to move on to our height gauge. You've seen me use it already kind of as a transfer gauge for the moment, but the height gauge itself, it measures in one axis very accurately. So as we rotate this dial and raise and lower the arm, we can attach an indicator or a scribe, and whichever tool we have, there's a counter on here and there's a counter here that will tell us how far this motion has traveled. So it's very accurate. It's a great tool to have in your shop. There's a lot of interchangeable tips. So we've got an indicator on there now, a test indicator. You can put a scribe on there. A drop indicator has some applications, although a drop indicator is more commonly used on a drop stand. Not too common to see them on this, but you certainly can. You can get a depth gauge attachment where, you know, a bar very similar to your caliper depth bar, although it's actually probably more related to the bar on a depth mic. But you can attach that to your height gauge and get down inside holes and inside for internal features and measure from the top of a part to the bottom of a step. There's surface roughness, so that just makes it easier to attach a surface roughness measurement device to the end of this, and you can raise and lower it onto your part and get some quick measurements that way. But the key is it only works on the surface plate. You can't use it on a workbench. It's got to be on a plate. It really has no meaning unless it's attached to a surface plate, because all of the accuracy of the height gauge comes down to this surface that's on the plate being very perpendicular to these bars that are that restrict the travel in one direction. If this bar is not perpendicular, the beams, that's the word I was looking for. If the beams are not perpendicular to the bottom surface, this gauge is inaccurate. So if it's at a perpendicularity this way or this way, it won't be usable. So some terminology you should know, like I was spacing for a moment there. You have the base, which is where you're going to grab it and slide it. You usually have some ergonomic places to grab onto it. You have the beams. This is a twin beam system, so I actually like these. They're very stable, rigid, and repeatable. There's also applications using single beams and even digital single beams, so different styles than this one, but I like this twin beam style. You have a counter right here and a dial indicator here that will be just showing you how far you've traveled. There's a lock, so when you lock this down, you can restrict it from moving. Make sure you don't make a mistake, or make sure that no movement of the gauge accidentally causes it to move. A lot of these end up wearing over time because it just applies a little bit of friction to the bar. So sometimes these don't always work, or they've been broken, but this one's a little bit worn, but it still works. And then you have a holder here where you can attach, you know, a test indicator bar or a scribe. But you just have a little clamp. All right. So there's one thing I wanted to talk to you guys about. When you are doing a measurement with a height gauge, you may notice that as you're going up and down with it and changing direction of the motion, whether you're switching from up to down or down to up, is you may get a little backlash. That's another error that you may experience besides perpendicularity error. And that just comes down to wear and some looseness that might develop, especially in the handle here. Like I can definitely make this handle move a little bit before the dials even move. That's not what I'm talking about. I'm more talking about when you're not repeatable, going back and forth, that would be a backlash error. So there's a quick way to check that, and we're going to use a scribe. So what we're going to do is we're going to grab our scribe and let's do a 3-inch block. I don't think a 4-inch block is going to look too good on the camera. And we're going to do a few checks. First check is we're going to use our block on the surface plate. We're going to zero out the gauge on the bottom here on the surface plate. And then we're going to move up above the block, come down and take a reading. And then we'll do the next check where we zero at the top, we wiggle the bar out, we wiggle the block out, and we just go straight down. And we check our reading again. So the first check, we're going to go up above, change directions, and go back down. And then the second motion, we're only going to go down. And we should get the same reading if the height gauge is in good condition. So let's demonstrate that. All right. Got our height gauge, our 3-inch block. Now, hopefully you guys can see. So I've got 0 here. And remember to zero your counter on both levels, the inch and the metric, just so you don't end up confusing yourself. So I got 0 there. You can't really see it on the camera. And we're going to go up above the block and then lower back down onto it. Should be reading 3 inches exactly. And I've got a little bit of resistance, and it looks like 3 inches to me. So I went up and down, I went up above it and back down, so I did do the change direction. Let me wiggle this out. All right. And let me just very gently show the camera that it is reading 0. There's a little bit of parallax there, which we're going to talk about. Basically, that means since you're not looking directly straight on, it may look different, but when I look directly straight on, it's reading 0. So I've zeroed my counter again, and now we're just going to go straight down. And we should get a 0 again. Actually, we should get 3 inches, I should say. And I've got 0 again at 3 inches. So let me tip the gauge for you. Zero. So it's traveled exactly 3 inches. Now, if you had a backlash error, you might have seen something off 0 at one of those points. But this height gauge is not having an issue. Okay. Now, for calibration, it's going to be a very similar procedure, but you're going to use multiple Joe blocks. So what it's saying is, with a lot of gauges, we zero it at one extreme when they're closed, when they're zeroed, and then maybe we check it at the other extreme, like a micrometer, we'll check it at its full stroke. With a height gauge, this has got 12 inches of stroke, so there's a lot of potential error where it might be more accurate down at the bottom, but in the middle, where it gets used a lot, maybe it wears and it's no longer accurate, and at the top, it's back to being accurate again. That's something you need to look for. It doesn't really do you any good if the gauge fails in a certain position and you don't know about it, which is common for height gauges. So what we're going to do, ideally you would do the entire stroke with maybe with a specialized gauge. I'm going to check, let's check 4 inches. So we'll check at 1 inch, 2 inch, 3 inch, and 4 inch, and we'll just check there. And you can set up more Joe block stacks or buy I think it's called a Cadillac gauge, to check the full travel of the height gauge. But what you're going to need is Joe blocks that are calibrated, and a surface plate that's calibrated, and a scribe. And we're just going to check each one. And the key to this, as I mentioned, a calibrated surface plate, a calibrated Joe block. The only thing that we're checking now is the height gauge. We're assuming that because the surface plate is calibrated and the Joe block is calibrated, this is the only thing we're isolating this one from the equation and then checking that to make sure that it's correct. So I'll get my gauges, my 1 inch, my 2 inch, my 3 inch, and 4 inch. And just set those aside. We'll start off with the 1, and first thing I'll do is zero it. All right, the dial indicator here is reading 0. And I hit my 2 counters already. I will go to 1 inch and pretty much hit 0 again, so it's exactly 1 inch. I'm not going to keep tipping the height gauge, so I'll just keep telling you. Now we're going to go up to 2 inches. And once again, we're back at 0, meaning we've traveled exactly 2 inches. I'm going to go up to 3 inches. All right. I'm going to remove the parallax error by looking directly on it. And again, we're at 3 inches. So far, it hasn't had any issues as we travel up and down. And you want to use kind of a light touch when you're doing this because you can crank on this handle and jack up the height gauge and put it at a weird angle. So if you'll notice, I'm kind of grabbing from the outside. I'm not using this little handle. It's fine to use this when you need to travel a big distance, but as you get closer to the part, use the outer handle and just let it kind of slip, let your fingers kind of slip off it when it meets resistance. And let's take a look. At about 4 inches, I've got a little bit of error. I've got maybe about a 0.5 thousandths error. So it could be that, just like I was saying, the middle of this height gauge is a little bit worn and it's not so repeatable at the 4-inch level. Now I should keep going maybe, and you don't have to go every inch, but from 4 inches, maybe you go to 8 inches, 12 inches, or maybe you go every 2 inches. You can decide that. You have to justify it, but pick something that's reasonable. Okay, but otherwise, I've got a little bit of error. We're not going to be measuring anything larger than 4 inches with this part, so we're going to keep going for this video. But really, at this point, I might service this a little bit, clean it, tighten some things down, and that should be all it really needs. Clean it and double check that it's tight. If there are some pieces that have worn, you may need to replace those through the manufacturer, but for this, we're not too concerned for the training video. All right. Now, well, here we go. Here's a picture of the calibration. So you couldn't see the indicator, but I took some pictures of at 0, at 1 inch, and at 4 inches. So that's pretty much the procedure for every height. Now, before we move on to the test indicator, I want to spend a little bit more time looking at this height gauge by itself. So we're about 30 minutes into our video, and so we have a little bit of time. Oh, yeah. So I'm gonna measure a 3-inch block again, and 0. All right, so I've got 3 inches. Yeah, pretty much exactly. We'll wheel this out. Now I want to spend a little time to look at the counter. And remember, I've put it at 3 inches. So when you're looking at a height gauge, you're going to be looking at the counter and the dial. So right now I've got it on 3 inches exactly. So it says 3.0 on the counter, and over here the dial says 0. Now I'm going to very carefully raise the height gauge. Let's say 30 thousandths. So how do you read this? So you take a look at 3 inches, right, and 30 thousandths. And as we keep going up, you'll see the counter has moved. Now I'm between 0 and 1, so I'm somewhere in between 3.0 and 3.1. And that's how you read these. It's kind of like the vernier scale. Sometimes you're in between on the counter, and you use the dial here to give you exactly where you are. So now I'm at 3.0 and 64 thousandths. Now, what people tend to do, they'll make a mistake reading this because they'll take a look at the counter and they'll think they're wrong. So I'm going to randomly put this somewhere and let's take a look at what it reads. So right now, well, this is actually not a good example because it's so unreadable that it doesn't show up on the camera. How about this one? So what do we read right here? 3, right here I see a 3 and I can really see the 8, so 3.8 and 87 thousandths. Now a lot of people would see that and assume it's 3.887 and that would be incorrect because they can see that 8 very clearly. They say to themselves, all right, I'm already at 3.8 and I'm at 87 thousandths. But what happens when you think you're going to 3.9, you're only 13 thousandths away. Oh, well now you're still at 3.8. It hasn't moved. So what these counters can do sometimes is they won't be that accurate in their motion, that precise. So this is actually 3.7 and 87 thousandths. So even though I can see the 8, I'm actually between the 7 and the 8. And I haven't quite gotten all the way. So just remember that how you're going to determine that is where are you in relation to 0? Are you almost to the 0? Or are you past the 0? And that will help you figure out where you are in your counter. Now some more modern gauges won't have a counter. They'll just have a digital display. But if you use one of these, this is one of the not one of the drawbacks, but one of the difficulties of using a counter is just making sure you're reading it correctly. I've known some people that when they're traveling, they'll actually count how many circles they have just to make sure they don't make a mistake, and I do that as well. Sometimes when I've set up something critical and I just don't want to make a mistake, I'll just watch it and count. Another tip I want to give you guys, I mentioned it before, when you're zeroing, make sure to zero both the inch and the metric, just get in that habit so you don't look at one or the other, because sometimes your inch reading and your metric reading might look the same or close to the same if you didn't zero one of them. So just try to get in that habit. And as for moving around the height gauge and picking it up, you'll want to slide it around with the base, grabbing onto the base. Try not to grab onto the twin beam at all. Don't squeeze these. You'll notice whenever I'm handling it, I'm kind of lightly grabbing it at the top, just stabilizing it, and I'm really putting all the weight here at the base when I pick it up and I move it somewhere else. And when you want to put it back on a height gauge, what you can do is you can kind of tip it on a back surface and slide it on this way. So again, don't grab here. Be very careful. Even when I was kind of tipping it and showing you on the camera, I really don't recommend putting that kind of pressure on the system. I was trying to be as careful as I could about it, but you could very easily make a mistake. So just keep them vertical and slide them around by holding onto the base. All right. So that's pretty much all I have to say about the height gauge itself. But, I use the scribe attachment. We're going to switch over to using the test indicator attachment. So we can slide that off and put our test indicator on and talk about how we use the test indicator. And in fact, completely wrong move. The test indicator is one of the great features of using a height gauge is to get this test indicator, because it can give you some very discrete readings of what's going on. You can buy these with resolution at a 0.5 or 1/10. So and actually even finer than that. There's digitals. There's all kinds of styles. So you can really get some good resolution out of these gauges that you don't get with a with a scribe. With a scribe, all of your resolution comes from the dial here, but with an indicator, you can get much finer resolution. And what it'll do is it'll take this tip and just measure how far it moves up and down. So it's not moving it, measuring any side-to-side motion or anything like that. It's only measuring how far this deflects up and down. Now your typical stroke is going to be 30 thousandths on a good indicator. That'll be like your everyday common use indicator. This one I have loaded as a 60 thousandths, so I can get more travel out of it than a standard indicator. Well, actually, now that I look at it, it's like 45 thousandths or so. So I would say this is a 30 thousandths indicator. But you can actually get them when they get to the really fine resolution, that 1/10 that I mentioned resolution. You're only going to get like 8 thousandths of travel out of it. So it's a very precise gauge for a very precise measurement, but you don't get as much travel. This outer ring will rotate for 0, so you can just set 0 like this. You don't always have to set 0 by applying the right amount of pressure. And this angle here, you can rotate horizontally, or you can change the angle and go vertically. However, whatever inspection you're doing, or anything in between, you just kind of gently and purposefully change the angle to what you need it to be. And I do want to point out you can over travel these, and I'll show you an example of that. But basically, when you over travel it, that resting angle that you put it at, that free state angle, it will change and completely invalidate your reading if you just apply so much pressure that the angle changes. So I'll demonstrate that when I start using this. So why do we use this and not a scribe? Well, these gauges are great for sweeping something. So you could sweep a surface, find the highs and the lows of the surface. You can put a round part in a V block, and you can find the diameter sizes and runouts. Well, size is going to be a very specialized application, but it's possible. But you can find some runouts and parallelisms, flatness, perpendicularities. So all that's possible when you attach it to a height gauge. Now, you don't always have to attach it to a height gauge. You can get it on a more stationary gauge, but it limits the use because you generally like to be able to make this travel a large distance and take your measurements. So again, when it's attached to the height gauge, you can adjust the angle of the indicator. You can adjust the oh yeah, so I was confusing myself for a second. You saw me do this already. You can adjust not only the tip itself by changing its deflection, but you saw me run out of travel earlier, and I changed the whole resting angle of the indicator by loosening the clamp that holds it down and just changing it. So typically you don't really need to. Typically you'll find an angle that works for everything you're doing and leave it there. But occasionally you might need to change it for some clearance reason, like I experienced earlier. So how do we use it? It's just kind of like the scribe when we take it down and we zero on the surface, and then we can raise and lower our height gauge to find some distances. And we'll read the distance traveled will be read off of the height gauge well, mostly the height gauge and sometimes the test indicator. I'll show you a couple of examples of how that works. So, let's do a quick measurement. If I were going to measure the step height of this block, the angle block drawing says it should be 3.210. can't see that on the screen there. It should be 3.210. So how we're going to do that with the indicator, we're going to pick a horizontal angle. We're going to talk about why in a minute or two. But I'm going to bring this down, and I need to zero it here, and on the dial, and on the counter. So I'm going to bring some pressure, and I like to go about halfway through the travel. So if you have 30 thousandths of travel, if you apply about 15 thousandths of pressure, you have a plus or minus 30 thousandths or plus or minus 15 thousandths to work with. Now some other people only like to put maybe 5 thousandths of pressure because the more pressure you put, the more potential air you're adding. So it makes sense to go with a very light pressure, but when they only apply 5 thousandths, sometimes the indicator just falls off of the part. And so you lose all that air. So I like to go halfway. So if we're at 0 at the top, or it's not touching right now at the top, when I bring it into contact with the surface plate, that's about halfway, and then I'll bring 0. And then I need to zero the dial on the height gauge. Again, I'm trying to avoid parallax there by looking right at it. And then I need to zero the counter. So now all 3 places were 0. And now we can start to raise our indicator. And we're going to bring it into contact with that step surface, and we have to bring this to 0. And we cannot touch the dial to re-zero it, or else our measurement is invalid. So we have to use a light touch. And there you go, right on 0. And now we can read the dial to see how far we've traveled. So I'm at 3.213. And our print asked for 3.210, plus or minus 5 thousandths. So we're in tolerance at this point. And now I have the option, I can slide the part around. Ooh, and now I take a look at my indicator, it's dropped off by 2 thousandths. Now I'm back to 0. And now I'm back to 0. But over here, it's dropped off by 2 thousandths. Oh, here we go. So there's a little low spot here. And now we're using the indicator to adjust our math. We know our height gauge is 0 at 3.213. But now our indicator over at this point is down, well now we're about 2.5 thousandths. So what would that be? 3.210 and 5 tenths. So now we're involving a little bit of math there to look at the entire air. And you have the option to slide the part around. You also have the option to slide the indicator, the height gauge around and look at what you get. I tend to just slide whatever's easiest. So I tend to slide the part if the part is smaller and easier to move and stable. And I'll move the indicator if the part is large and I don't want to move the part around. I'd rather move the indicator. So that really is a choice you make each time you use it. Now let's, just for sanity check, let's grab our caliper and measure that with our caliper. So 3.212, pretty close to what we got with the indicator. And let's check that low point that was right on the edge. 3.212. Maybe the caliper's not picking it up because of the way the jaw, it's registering on a very large jaw, and our indicator point is so small, it's picking up something else. So that's one of these instances where, yes, the height gauge is more accurate than the caliper, but they're operating in different ways. So it can be hard to compare apples to apples when this is grabbing a smaller surface area than the caliper is. So I really don't have, I just be aware of it. It doesn't. I would trust the height gauge because it is more accurate, because of the indicator accuracy, and I'm able to get inside those smaller points. But you could have a perfectly good part and get different readings as well, because they just operate in with different methods. So just keep that in mind. Now, for the next thing I'm going to show you is how to calibrate. And we showed you how to calibrate the height gauge earlier, and we were using the calibrated surface plate and the Joe box. And we're going to do that again with the indicator. Oops. We're going to do that again with the indicator, but we're not going to involve the movement of the height gauge, because that would introduce a level of error that we don't want to introduce. So how we do that is we pick a low point relative to the rock, and we just lock it in place and change the size of the Joe block that's going in there. And we slide different Joe blocks in there. If we slide a plus 5,000th Joe block, we should receive plus 5 on our indicator. If we see minus 5 on the Joe block, a minus 5 on the indicator. And it's pretty much just that simple. Of course, again, you need a calibrated surface plate and a calibrated Joe block so you can isolate just the indicator. We're not going to move the height gauge, so I'm going to lock it in place. Well, actually, once I zero it. So I've got the 125, and I'm going to go halfway through my travel here and zero U. All right. I'll lock my height gauge, and I don't need to worry about zeroing here because I'm not using the height gauge at all. I'm only going to be changing the Joe block size. So one thing that's smart to do is slide your block off and slide your block back on and make sure you're still on 0. I'd say about 1 out of 5 times this isn't true because of some weird pressure that built up in my zeroing, or maybe a piece of dust or something. But once I re-zero it and can get repeatable 0, everything's good. So that's the 125. Let me slide the 127, and I should see a plus 2 thousandths. And I do. Let me slide the 130. I should see a plus 5 thousandths from 0. And I do. Starting to see a little bit of error, maybe like a 10th error. Let's try the minus 5. So we're going to grab the 120. Again, I zeroed on a 125. So when I slide a 120, I see a minus 5. And I see pretty good. Let's try even smaller. Let's try a 115. 10 thousandths different. And see, pretty good. And let's do one last one. We'll do a 135. That'll be a plus 10. And that should give me a pretty good stroke check. And I see a little bit of error, 1 or 2 tenths. So it could be that as more pressure is being applied, there's more error. I'm not too concerned about it for this training video. For a real life situation, you'd have to compare how much error is allowable. And in fact, a tenth of error is usually acceptable. There has to be some allowable error in a calibration. So I wouldn't worry about it too much. I might try to tighten the needle again, maybe clean it. There may have been a chip or some coolant that got in there. But otherwise, this is looking pretty good and usable for our training purpose. All right. Now, we got to talk about cosine error for a minute here. Cosine error is involved in every measurement, and it has to do with the angle that you make with your tip. And, you know, the rule of thumb is basically keep your tip horizontal or within 15 degrees at most, because as you change error, you're going to get more and more error, or change angle, you're going to get more and more error. So, how do I say this? You know, I have a function here of how you can sort of not predict, but explain it. So if your cosine at an angle is multiplied by the true displacement, you'll get a little bit of error versus at different angles. So if you're, first, how do I explain this? If your true displacement if we do that same Joe block test and we change how thick the Joe blocks are, if your true displacement change was 20 thousandths and your TIR shows 0.0197, well, your cosine error is 3/10. And that can just be due to how much angle you had on your tip. And that would be a 10 degree error, or a 10 degree resting angle relative to the surface plate, could lead to 3/10 of error. You don't know, it's not a true prediction, it's just the way the physics works, the way a triangle works, but it is representative of what happens. And I don't always see it. You don't always see it because you leave your angle at the same place every time, and you don't do it with this. You don't check with your Joe blocks all the time. But, the way it works is essentially, when you're measuring a surface with a Joe block, or with a surface plate and an indicator, as it goes into the dips and the valleys, the indicator is bouncing up and down, up and down, up and down. So when the indicator is at a very extreme angle, well, some of that motion has to go left and right in order for this to move up and down, at just a little bit of an angle. If it's entirely horizontal, then there's no side-to-side motion and all of the movement is up and down. But as the angle gets more extreme, there's more motion side to side, which gets lost. It doesn't get picked up by the indicator. You're only picking up the vertical motion that gets translated out here. So this is how it works. And as an extreme example, if you looked at some different angles, if you had 0 degrees on a 20 thousandth displacement, you should see 0 error. 5 degrees, you would see 1/10 of error. 15, you're going to see 7/10 of error. As I said, that's getting kind of big, and that's, we're still saying 10 to 15 degrees is acceptable. 45 degrees, man, you're seeing 5 thousandths, almost 6 thousandths of error. And at 60 degrees, 10 thousandths of error. So I'll demonstrate that really quickly, just for a couple of angles. So let's grab our 125. When you just saw me go through this with about a 10 degree angle. Here's my 125. So I'm gonna extremely change this angle. Now I'm probably close to 45 degrees. And here's the 125. I'm going to zero on the 125. Okay. And let's grab the 130. So I should see a +5. And I can barely even get the thing on there. And I see a plus 2 thousandths almost. So 2 thousandths of error. Let's try the minus. So I'm 0 at 125, and let's try the 120. And again, I'm not at -5, I'm at about -4. So it's not even consistent, right? Should have been probably symmetric if it were a true actual equation that you could follow. So yeah, maybe I'm closer to 30 thousandths, but it doesn't really matter. The point is, keep it horizontal. You need a little bit of angle sometimes to just be able to use the part. If it's perfectly flat, you're going to crash into your indicator body very quickly. So you do need to have a little bit of error, a little bit of angle, so that you can clear the body of the surface. Actually, let's do it right here. So if you don't have at least a little bit of angle, you won't be able to slide your part around. You'll crash into the body as soon as you try to go under it. So it's just a rule of thumb. If you follow it, you really won't have any problems. It's called cosine error. So keep this flat or within 15 degrees, and you really shouldn't see too much of a problem. When you get tighter and tighter tolerance, then try to get it as flat as you can and minimize the error that you introduce. So we're gonna pause right here, and next up we're gonna talk about the drop indicator in the next video. So I do want to thank you guys for watching, and I want to thank Laney College for providing this part real quick for me to demo, and we're gonna keep using it. But that's Laney College in Oakland, California, the machine technology program. But let's take a quick break and continue on with the drop indicator.